Anyone who studies judgment and decision-making soon encounters several influential models of rational choice. Expected utility theory, bounded rationality, prospect theory, and multi-attribute utility theory all remain influential today. Yet they seem to make different assumptions, emphasize different aspects of decision-making, and sometimes even point in different directions. At first glance, these models can be difficult to reconcile. They emphasize different assumptions, focus on different aspects of decision-making, and sometimes appear to lead to different conclusions. It's natural to wonder whether they are competing theories or whether newer models have simply replaced older ones. The statistician George Box famously observed that all models are wrong, some are useful. At first, that statement may seem strange. If a model is wrong, why would scientists continue to use it? The answer is that scientific models are not judged by whether they capture every aspect of reality. Instead, they're judged by whether they help us understand, explain, or predict important aspects of the world. Every model simplifies reality. Every model makes assumptions. And every model has a particular scope, a set of questions it was designed to answer. Decision-making research provides an excellent example of this idea. Rather than asking which model is correct, scientists ask a different set of questions. For example, what question was this model developed to answer? What assumptions does this model make? What does this model explain well? Where does this model's explanatory power begin to break down? In this video, we'll examine how several influential models of decision-making emerged in response to different scientific questions. We'll see that they were not all designed to explain the same phenomena, and therefore need not compete with one another. Instead, each contributes a different perspective on judgment, decision-making, and rational choice under uncertainty. To see why multiple models of decision-making exist, it helps to begin with the first major question researchers tried to answer. How should a rational person make decisions when the outcome is uncertain? At first, the answer seemed straightforward. A rational decision maker should choose the option with the highest expected value. That is, the average outcome we would expect over many repeated decisions. By weighting each possible outcome by its probability, expected value provided a simple mathematical rule for making decisions under risk. For many problems, this approach worked remarkably well. But as you may remember, it also produced one of the most famous paradoxes in the history of decision theory, the St. Petersburg paradox. The game is simple. A fair coin is tossed until it lands on heads. If heads appears on the first toss, you win $2. If it appears on the second toss, you win $4. On the third toss, you win $8, and so on, with the prize doubling after every tails. Because the potential winnings increase without limit, the game's expected value is extraordinarily large. The question is, how much would people pay to play this game? According to expected value, a rational person should be willing to pay almost any finite amount to play. Of course, most people wouldn't. Even if you understood the mathematics perfectly, you probably wouldn't risk your life savings for a single chance to play this game. Bernoulli argued that the paradox revealed something important. People don't value money in purely objective terms. The difference between $1,000 and $2,000 is much more meaningful to someone with limited resources than to a millionaire. In other words, the utility of money depends on the person receiving it. And each additional dollar generally provides a smaller increase in utility than the one before it. Bernoulli's insight changed the way researchers thought about rational choice. Instead of asking how a rational person should maximize expected monetary value, they began asking how a rational person should maximize expected utility. The modern mathematical theory of expected utility wouldn't be fully developed until the 20th century, but Bernoulli's recognition that subjective value matters became one of its central foundations. The scientific question stayed the same: how should a rational person make decisions on certainty? What changed was researchers' understanding of what should be maximized. Objective value alone was no longer enough to explain rational choice. We needed utility. Bernoulli's insight proved remarkably influential. Over the next 2 centuries, economists, mathematicians, and decision theorists continued to refine the idea that rational choices should be evaluated in terms of expected utility rather than objective monetary value. In the 20th century, John von Neumann and Oscar Morgenstern provided the mathematical foundations for what we now recognize as modern expected utility theory. For many decision problems, expected utility theory proved extraordinarily successful. It provided a mathematically rigorous framework for analyzing choices under risk and became the dominant normative model of rational choice in economics, decision making, and other fields. Even today, it remains one of the cornerstones of decision science. Like any scientific model, expected utility theory rests on a set of assumptions. It assumes that decision makers can identify relevant alternatives, that they can evaluate their consequences, and that they can determine which option maximizes expected utility. These assumptions provide a useful standard for ideal decision making and laid the foundations for later developments in decision science. Understanding the scope of expected utility theory helps explain why it remains so influential. Its greatest value lies in providing the rigorous normative standard for decisions under uncertainty. Within that scope, it offers a powerful framework for evaluating rational choice and serves as a benchmark against which other models can be compared. As researchers sought to apply this normative framework to increasingly complex decisions, they encountered situations that could not easily be represented by a single utility function. Choosing a college, purchasing a home, selecting a medical treatment, or evaluating public policy often requires balancing numerous competing objectives. Cost, safety, convenience, quality, risk, ethics, and personal preferences may all matter simultaneously. This led to a new question: how should a rational decision maker analyze complex decisions involving multiple competing objectives? Researchers have developed a variety of prescriptive approaches to address this question, collectively known as multi-criteria decision analysis, or MCDA. These approaches extend rational decision making to situations where choices involve multiple dimensions that can't be easily reduced to a single measure. For example, multi-attribute utility theory, or MAUT, provides a structured process for identifying the relevant decision criteria, assigning weights to reflect their relative importance, evaluating each alternative, and then combining those evaluations into an overall assessment to help somebody make a decision. Understanding the scope of multi-criteria decision analysis helps explain why these approaches are widely used in practice. They're particularly useful when decisions involve multiple competing objectives and trade-offs must be considered explicitly. Within that scope, frameworks such as MAUT help decision makers organize complex information, clarify competing priorities, and evaluate alternatives systematically. Although expected utility theory and MAUT were developed to address different kinds of decision problems, they do share a common objective: identifying the optimal course of action. Both assume that decision makers can gather the relevant information, evaluate the available alternatives, and determine which option best achieves their objectives. Herbert Simon questioned whether this conception of rationality was realistic for human decision makers. Rather than asking how an ideal decision maker should optimize a choice, Simon asked a different question. What does rational decision making look like when people face the limitations of everyday life? Simon answered this question with the concept of bounded rationality. He argued that rational decision making must be understood within the bounds imposed by human cognition and the environments in which those decisions are made. These bounds include limited time, incomplete information, finite attention, and limited computational capacity. Real decision makers rarely have the opportunity, or even the ability, to identify every alternative, gather all the relevant information, calculate every possible consequence, and determine which option actually maximizes utility. For Simon, these limitations don't represent failures of rationality, they define the conditions under which rationality operates. A theory of rational choice, therefore, should begin with realistic assumptions about human capabilities rather than idealized assumptions about unlimited knowledge and computation, according to Simon. One important implication of this idea is satisficing. When searching for the optimal decision is impractical or impossible, decision makers often stop when they find an alternative that meets an acceptable standard. Simon argued that under many real-world conditions, this is not simply a practical compromise, it's an adaptive and a rational response to the constraints of the environment. Understanding the scope of bounded rationality helps explain its enduring influence on decision science. It's especially relevant when theories of rational choice are evaluated against the realities of human cognition and real-world decision environments. Within that scope, bounded rationality provides a framework for assessing whether the assumptions underlying a model are realistic for human decision makers. Simon's work represented one important direction in the study of human decision making. Another focused on understanding the psychological processes underlying decisions made under conditions of risk and uncertainty. That work began with a different question. How do people actually make decisions under conditions of risk and uncertainty? In the 1970s, psychologists Daniel Kahneman and Amos Tversky began investigating this question experimentally. They sought to develop a psychological account of how people make decisions under conditions of risk and uncertainty. Across a series of influential experiments, they discovered that people's judgments and choices followed systematic patterns. Decisions were influenced by how options were framed, whether outcomes were perceived as gains or losses, and how people subjectively interpreted the probabilities. These patterns were consistent and predictable, suggesting that they reflected fundamental psychological processes rather than random errors. This work culminated in prospect theory, a descriptive model of decision-making under risk. The theory characterizes how people evaluate risky alternatives, accounting for both decisions that are consistent with expected utility theory and the systematic departures observed in phenomena such as framing effects, loss aversion, reference dependence, diminishing sensitivity, and probability weighting. Understanding the scope of prospect theory helps explain why it complements rather than replaces earlier models. It enables researchers to identify the situations in which psychological factors systematically influence decision-making, while clarifying the situations in which the predictions of expected utility theory remain consistent with observed behavior. Stepping back, We can now see that these models were never all trying to answer the same question. Expected value and expected utility theory address the question of how an ideal decision maker should choose under uncertainty. Multi-attribute utility theory extended that tradition by providing a structured prescriptive approach for analyzing decisions involving multiple competing objectives. Herbert Simon, introducing bounded rationality, broadened the concept of rationality by asking what rational decision making looks like under the realistic constraints of human cognition. Kahneman and Tversky pursued a different question, developing prospect theory as a descriptive model of how people actually make decisions under conditions of risk and uncertainty. Seen in this light, the relationships among these models become much clearer. They were developed to answer different scientific questions, and each contributes a distinct perspective on decision.